Let's take a look at this problem here. You want to mix a 15% milk solution with a 40% milk solution to get 50 liters of a 30% milk solution. How many liters of each solution should be used? Okay, so let's see what we have with the picture here. So what we have is that we have a 15% milk solution is being mixed with a 40% milk solution to create a 30% milk solution. In terms of volume, we have 50 liters of a 30% milk solution. That is, the final volume is known, and that happens to be 50 in this case. As for the amount of volume here, we don't know how much we have. So we're going to let X be the number of liters of that 15% milk solution. So that means this would be X. Well, if this is X, this has to be the total, which is 50, minus the amount of volume here. So that would be 50 minus X. Now, from here, we can create the equation. Remember, it's the concentration times the volume plus the concentration times the second volume should equal to the final concentration times its final volume. So if we do that, we get the following equation. Now, the 0.15, that basically comes from that 15%, right? Percent is always out of 100, so 15 divided by 100 would give you that. And then, of course, you get the same thing with those. Now, the next step here would be to distribute. If I distribute the 0.40 times 50 is 20, and 0.40 times that would give you a negative 0.40. And then, of course, over here, you get 15. Combine the like terms, 0.15 minus 0.40x gives you a negative 0.25x, and then you still have the plus 20 equals 15. Subtract the 20 over to the other side. So 15 minus 20 gives you that negative 5, and then I can divide both sides by negative 0.25 to eliminate that number 0.25, or to isolate the variable x. So in this case, that will give you x equals 20. Well, what does that tell me? Well, remember, x is the number of liters of that 15% milk solution. So in this case, from here, we can say that we have 20 liters of 15% milk solution, and then 50 minus 20 would give you 30. So you have 30 liters of 40% milk solution. And of course, 30 plus 20 should give you the final volume, which is 50. Here is another problem. How many liters of 30% alcohol solution must be mixed with 20 liters of 50% alcohol solution to create a 40% alcohol solution? Okay, so here's what we know. A 30% alcohol solution is being mixed with 50% alcohol solution to create a 40% alcohol solution. We know that we have 20 liters of that 50% alcohol solution, so the amount of volume here is 20. We don't know how much volume we have here. So let's let X be the number of liters of the 30% alcohol solution. Now the final volume should be the sum of those two volumes. So that would be X plus 20. Now let's create an equation. Concentration times volume plus the concentration times volume should be the final concentration times the final volume. So we have the following. And then we can multiply this. 0.5 times 20 is 10, and then I can distribute this 0.40 to get this new equation. Now from here, I don't have like terms, and I don't have like terms here to combine. So the next step should be to move the variables to the same side and the constant numbers over to the opposite side. So let's subtract 8 on both ends first, and then we're going to subtract the 0.30x over to the right side. This gets canceled, and that gets canceled as well. Now, 10 minus 8 is 2, and 0.40x minus 0.30x is 0.10x. Let's get this out of the way, move that up. Now, in order to isolate the variable x, we have to divide by 0.10. Both ends, you get x equals 20. Well, x is the number of liters in 30% alcohol solution. So in this case, we have 20 liters of 30% alcohol solution. And the final volume should be 20 plus 20, which is 40. Here is example 3. You have 30 liters of a 20% alcohol solution. How many liters of pure alcohol, that is 100% alcohol, must be added to the solution to make a 40% alcohol solution? Okay, so we have a 20% alcohol solution is being mixed with pure alcohol, that is 100% alcohol solution, to create a 40% alcohol solution. We know that we have 30 liters of that 20% alcohol solution, but we don't know how much volume we have here. So we're going to let x be equal to the number of liters of that pure alcohol solution. So the final volume would be 30 plus x, which makes just 30 plus x. Now, our equation is going to look like this. Remember, concentration times volume for each condition here. And then if I distribute the 0.40 to this and multiply this out, I get the following equation. Before I go ahead, just know that this one is because we have a 100% alcohol solution. Remember, percent is out of 100, and 100 divided by 100 gives you the 1. That's where the 1 is coming from here. So let's go ahead and distribute. We get the following. Now, let's move the variables to the same side and the constant numbers over to the opposite side. So if I subtract 6 and subtract 6, you get 12 minus 6 is 6. And if I move this over to the other side, x basically means 1. And 1 minus 0.40 is 0.60 x. Right? Now, the next step would be to divide both sides by 0.60. You get x equals 10. That means we have 10 liters of pure alcohol solution being mixed with 30 liters of 20% alcohol solution to create 30 plus 10 is 40 liters of 40% alcohol solution. Here's a final example. A juice bar wants to mix two juices, one that is 20% orange juice and the other that is 50% orange juice. They are mixing 30 liters of the 20% juice with 45 liters of the 50% juice. What is the total volume of the resulting mixture? And what is the final concentration of the orange juice? Okay, so here's what we know. We have a 20% orange juice is being mixed with 50% orange juice to create a final concentration. In this case, we don't know what the final concentration is. So let x be equal to the concentration of the final orange juice. So that's going to be this. In terms of volume, we know that we have 30 liters of that 20% solution or orange juice, and we have 45 liters of that 50% juice. The total combination of those two should give you the final volume, which happens to be 75. So what is the total volume of the resulting mixture? In this case, that would be 75 liters. As what is the concentration of the orange juice? Well, we need to figure that out. So we're going to have to create an equation just like before. Concentration times volume plus concentration times volume equals the final concentration times the volume. Here's what the equation looks like. So basically, if you do 20 divided by 100, that simplifies into 0.20. So times that volume. Same thing here. Over here, since we don't know what the concentration is, it's going to be X divided by 100, whatever that percent is, divided by 100, and then times the final mixture. I don't like dealing with decimals and fractions, so let's go ahead and multiply everything by 100 to get rid of this 100. So if I multiply by 100, multiplying this by 100, basically what it does is it moves the decimal point to the right twice. So this is going to become 20, and that becomes 50. So you get the following here. And of course, this 100 would cancel out with the other 100, so you get a 75x here. Let's multiply this out. You have, this would be 600, and then over here would be 2,250 equals 75x. Combine the like terms, 600 plus that gives you 2,850 equals 75x. And now to isolate the variable x, divide by 75, you get 38%. So that means the final concentration will be a 38% juice, and the volume of that would be 75 liters.